Hello y'all, we are Memphis Communiversity and today we are doing another calculus done wrong lesson where we wrong calculus before calculus wrongs us. And today what we're going to be doing is we're going to be talking about limits. And I know you might be thinking limits sound pretty intimidating. Limits can be some of the hardest questions on calculus exams, but today we're going to keep it as a nice, gentle sort of level because we are only going to do limits involving infinity. And limits involving infinity might seem quite intimidating, but you're going to see that they're kind of some of the easiest questions on the AP exam, for example, both BC and AB, or even college calculus exams. They're some of the questions that take the least amount of time. You just look at the question and you don't even have to do any math, you just instantly know the answer. But first off, what do I mean by a limit involving infinity? Well, when you have a regular limit like x is approaching, for the example, the number 2, what happens is you examine function values close to the number 2. So you look at the function values at 1.9, 1.99, 1.999, 1.999, and you just see are those function values tending towards a number. But today we're not going to be going to numbers, x going to 2, we are going to be going to infinity or negative infinity. What does that mean? Well, that means that what we're going to do is we're just going to let our x's be bigger and bigger and bigger, because you can't really approach infinity because infinity isn't really a number, it's a concept. So we use the same notation, but it's a little bit different. All we're doing is letting x get bigger, 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 bigger if x is going to infinity, or x is going to negative infinity, we're going to let x be negative a million, negative a billion, negative a trillion, and so on. And you're going to see that this process isn't too bad, so let's get started. We're talking about limits involving infinity. Limits involving infinity to infinity and beyond. Let's just see what we got. So the first few practice examples that we're going to do, the first half of the video, we are going to be doing limits involving infinity of polynomials over polynomials, the ratio of polynomials. So these are always going to look at the form limit x going to positive or negative infinity. So instead of going to 2 or 3 or 7 or negative 5, we're going to either infinity or we're going to negative infinity. And then we are going to be doing the ratio of polynomials. So of course, polynomials are just the sum of powers of x with coefficients. So I'm going to write it in the more general way, but don't be too intimidated. So just a coefficient times x to the n plus another one all the way down to a1x plus a0. So this is just a polynomial, something like x cubed plus 3x squared minus 2x plus 1, something like that. And then what we're going to do is we're going to have a polynomial over a polynomial, so we need another one of these bad boys. So bm, we'll call it bm, x to the m plus bm minus 1 x to the m minus 1, all the way down again, b1x plus b0. So the b's are of course different than the a's because you might have a different polynomial. Just to be careful, we're using different letters to indicate the powers of our x's, because again, they could be different polynomials, like this one could be x to the third, this one could be x to the fourth. And what we're going to see is that these questions are very, very easy. We're going to call these the heavy questions, and there's going to be 3 different situations. Because we're dealing with infinity is kind of weird. And what we're going to see is that most of this actually doesn't matter. What matters is the leading exponent, because let's say you have x squared plus x plus 1 and you're plugging in a million. Well, when you plug in a million to x squared, that number is so big, it's so much bigger than the plus million, the plus 1 when you plug in 1 million into the rest of the polynomial, that it dominates. These guys are the bullies on the block. They are going to dominate everything right here, which makes the questions a little bit easier. We're going to be able to ignore all of this stuff, and we're only going to look at the leading exponents, the coefficients of the leading exponents of the numerator and the denominator, and compare them. Because they are just so much bigger when you plug in infinity. Infinity is so weird, but they're so much bigger when you plug in infinity that you can basically ignore all of this. And this is what we're going to do. And what happens is that there's going to be 3 different situations depending on how the powers of the leading exponent compare in the numerator and the denominator. So the first situation is that n is smaller than m. N is smaller than n. And what we're going to call that is we're going to call that bottom heavy. Basically, the bottom is dominating the top. If you think of it as a balance, I don't know, it's weighted more towards the bottom. So we're going to call that bottom heavy. So these are our three situations. The first one is bottom heavy, the best kind of heavy. Then there's going to be the situations when the leading exponents will match exactly. So that's n equals m. We're going to call that, guys, same heavy, because they're weighted the same. So for example, if the leading coefficient of both polynomials was x to the 6. Then the hardest one, but not too hard, don't worry. This is when n is bigger than m, meaning the numerator's leading exponent, doesn't matter about the coefficient, but the leading exponent is bigger than the leading exponent of the bottom. We're going to call that top heavy. And when my students do this, even after they do a ton of questions, they will write the words bottom heavy, same heavy, top heavy, and then they'll do the actual question. So once you recognize which one is which, what is the answer? Well, bottom heavy is the best one. Bottom heavy, the answer is going to be 0. Why is that? It's because the bottom is getting bigger and bigger and bigger compared to the top as you're going towards infinity, and as it gets bigger and bigger and bigger, if you have a number divided by a bigger number, as x is going to infinity, that denominator is going to dominate everything, so eventually you're going to be getting 0. Same heavy, it's going to be the ratio of the leading exponent, so it's going to be an over bm. So this is just the ratio. And then finally, top heavy is the reverse of bottom heavy. Basically, the numerator is getting bigger and bigger and bigger. The denominator can't keep up as x is going to infinity or negative infinity. So just getting bigger, bigger, bigger. That means that the answer is going to be either positive infinity or negative infinity. Just keep in mind that top heavy, in my opinion, will be the hardest one. Why is it the hardest one? Well, you do have to choose whether you want infinity as the answer or negative infinity as the answer. A valid answer for top heavy in both cases does not exist, because limits have to be numbers in order to have valid answers. So if the answer is infinity or negative infinity, a less specific answer does not exist. But again, what we're going to do is we're just going to look at the leading exponents, compare them, identify if it's bottom heavy, same heavy, top heavy, based off these the powers of the leading terms, and then depending on which one it is, we'll answer the question. So let's just see this in action, because in general it might be kind of confusing, but you're going to see again that these are the quickest questions that we can maybe manage to do. So let's erase this and let's put some examples up. So just erasing for fun. Let's see how this goes. So the first one I'm going to do is let's keep it simple. So limit as x goes to infinity. Again, we're doing it with infinity. And let's do x squared plus 3x minus 1. Let's do x cubed minus 2x plus 7. So we look at this limit. It's a totally different thing if x is going to a number, but x is going to infinity, because we're doing the video where limits are involving infinity. So we take that into account. We're just going to be approaching these limit questions so differently than if it was approaching a number. So because it's approaching infinity, we think in our minds, we need heaviness. Is it bottom heavy, top heavy, or same heavy? Remember that when you're dealing with infinity, the only terms that matter are the terms with the biggest powers in both the numerator and the denominator. So you cover this up and you're like, what is the biggest power? It's going to be x squared. So really, you can sort of ignore this 3x minus 1. It's just lovely. You don't have to worry about a large majority of the question. Then you do the same thing for the denominator. What's the biggest guy? X cubed. Again, you ignore the rest of the bottom, because x cubed will dominate the rest of the denominator as x goes to infinity. So now we have 2 and 3. So what's the leading exponent of the numerator? That's going to be 2. What's the leading exponent of the denominator? That's going to be 3. Last time I checked, 2 is bigger than 3, which means that we are going to be doing bottom heavy. We are in the bottom heavy case. So bottom heavy, I like to write bottom heavy. And as we introduced in the previous, or in the introduction, bottom heavy is the best kind of heavy, because that means you're just going to get the automatic answer 0. So just look how much work I did here. I didn't do very much work. All I did was compare the leading exponents, and I was like, oh, 2 is smaller than 3. That means the denominator is bigger. That means it's bottom heavy. The answer is 0. A 2-second question potentially. So let's do a slightly harder question, but not too bad. Let's do the limit as x goes to negative infinity. And then we're going to be doing 5x squared plus 3x minus 1, 6 minus 8x plus 2x squared. And to spice up our lives, let's change this to a minus. So, same sort of situation. We see that we are going towards infinity or negative infinity. In the previous question, if it had gone to negative infinity, it doesn't matter because bottom heavy is always 0. Same thing with what this question will be. This negative infinity doesn't really matter too much. The answer will be the same with infinity. It's only with top heavy questions, which we'll see later, and potentially harder variations of this question right here, where you do have to worry about the negative. So don't worry about the negative for now. What we're going to do is, again, look at the biggest term of each the numerator and the denominator in terms of the exponent. So it looks like in this one, it's going to be 5x squared. So I'm just going to ignore this guy right here. I'm not very creative. Notice it's the same as the previous one, but again, we don't care about it all. Just be careful at the bottom. Sometimes math teachers are a little bit tricky. So they're going to change the order. So notice that the biggest guy is this guy, minus 2x squared. So we're going to ignore this. So let's compare the leading exponents. Well, it's 2 and 2. 2 is equal to 2. So that means that we are now in same heavy mode. Same heavy isn't too bad. So same heavy, the answer is just the ratio of the leading coefficients. Leading coefficient of the numerator is 5 for the numerator. That's what I just said. And then negative 2 is the ratio, the leading coefficient of the denominator. So the answer is just 5 over negative 2. Again, such a quick question. Certainly not complaining if I see this on a math exam or anything like that. So remember, bottom heavy, always the answer is 0. Same heavy, if your powers are the same, that means that your answer is the ratio of the leading coefficients. So this might be too easy. Let's try to do a harder question. Let's try to challenge our brains, because every once in a while we should challenge our brains. So in my opinion, the hardest one is top heavy. Spoiler alert. The next one will be top heavy. Let's just see it in action. So let's do a top heavy question. So we have a limit as x goes to infinity, and we're going to have x cubed plus 3x squared minus 1. Let's just do the same exact thing. I don't know why my brain isn't very creative today, but sometimes you gotta let it rest. Next thing I'm going to do is x squared minus 4x plus 3. So this is going to be my next question, but we're going to see how that's different than, let's do 2 questions at once. Let's do this one. X to the 4th plus 5x minus 6 over x squared minus 8x plus 1. And then we'll just do even a 3rd question and just see how all of these are different. So limit as x goes to negative infinity over x to the, let's see, what do we want? Let's do x to the 5th minus 3x to the 4th plus 2x cubed over x squared minus x minus 1. So these are going to be our 3 different limits. These are going to be our 3 examples of top heavy. So first off, why are each of these limits top heavy? Again, what you want to do is you always want to find the leading exponents of each of the numerator and the denominator. So here it's 3 and 2. 3 is bigger than 2. So this is going to be top heavy. Same thing for this one. You have 4 and 2. Nothing too crazy. Same thing for this one, 5 and 2. Always, for all 3 of these questions, if you can tell this is a 5, not my greatest 5 in the world. If you can't tell this is a 2, not my greatest 2 in the world. But what are you going to do? But in each case, notice that this is going to be top heavy. So I'm going to try to write it sideways to be fun. All of these questions are top heavy, because the leading exponent of the numerator is bigger than the leading exponent of the denominator. So what happens is, just like with same heavy, bottom heavy, you can ignore anything that's not the leading exponent. So let's just cross out all the stuff that doesn't matter. So now what we're going to do is we are going to determine the answer. And top heavy, the answer is either 2 things. The answer is either infinity or the answer is negative infinity. Because when you plug in that x, the numerator is dominating, so it's just whatever the numerator and the denominator is going to be in terms of signs. So when you're going to infinity, it's not too tricky. When you plug in infinity, everything is going to be positive, so the answer is going to be infinity. So again, in top heavy, the answers are either infinity or negative infinity, and you want to just plug in infinity or negative infinity into the leading exponent and just see what you get. So let's try to see that in action. Here we have another top-heavy question, but we have negative infinity, and we should be careful of negatives when we're doing top-heavy. So what happens is you're going to plug in negative infinity into the x to the fourth. And all you're going to see is, do I get a negative number or not? Or do I get a positive number or not? Then we're going to plug in negative infinity into the leading exponent or the leading term of the denominator as well, and then we're going to compare the signs of both the numerator and the denominator. Keep in mind, because we're doing heaviness, because we're doing limits involving infinity, when you do this process, you only have to plug it in to the leading exponent, the leading term, because again, the other terms don't matter. So let's see what happens when you plug in a negative infinity. Well, when you plug in negative infinity, when you raise that to the fourth, negative 1 to the fourth is going to be even. So all of this is going to be positive. When you take limit as x goes to negative infinity of this polynomial, the entire thing is going to be positive infinity. Because when we plug in negative infinity, when you raise that thing to the fourth, that negative cancels out. Same thing with the bottom, because negative 1 times negative 1 is positive. It's 1, of course. So negative infinity times negative infinity, those negatives will cancel out. You're going to get positives. So what is a positive number over a positive number? That's just going to be infinity. So hopefully you can see what I'm doing here. Again, I'm trying to determine, do I want positive infinity or negative infinity as the answer? And I'm just plugging in the infinity that the x is approaching to into the leading terms and just seeing, do I get a positive number or a negative number? Do I get a positive number or a positive number? And so on. So let's practice this one more time. So when we plug in negative infinity to the fifth, the infinity certainly grows, but the more important thing is what happens to the negative. Well, when you plug in negative infinity to the fifth, negative 1 to an odd number like 5 is going to be negative still. So what we're going to happen is we're going to get negative infinity in the numerator. Then when you plug in negative infinity into the bottom, negative infinity squared, so those negatives do cancel out, so you're going to get something positive in the bottom. And what happens when you have a negative number over a positive number? That's just going to be negative. And remember that in top-heavy questions, the only possible answer choices are infinity or negative infinity. So when we have a negative or a positive, looks like our answer is going to be negative infinity. So hopefully that process makes sense. We'll recap it and then we'll do some slightly harder questions. So the process again is plug in, or first recognize that it's top-heavy by seeing that the leading power of the numerator is bigger than the leading power of the denominator. Then what you do is ignore everything that's not the leading powers of each the numerator and the denominator. So we crossed out all this stuff. Then you plug in the appropriate infinity depending on which one you're going to. See if that numerator is positive or negative or positive based off negative exponents of negative numbers. So negative numbers to even powers are positive and negative numbers to odd powers remain negative. Then you just see the ratio and you're like, oh, do I want negative infinity or positive infinity? So in this first one we had positive over positive, that made it positive infinity. Second one we had positive over positive infinity. Third one we had negative over positive because we plugged in negative to a fifth and negative to a square, so that answer was negative infinity. So just be careful about those top-heavy questions. Take 2 seconds to try to think about, do I want positive infinity or negative infinity? So let's do a variation of same heavy that sort of uses this idea. So I'm going to erase this board here. Again, I do heaviness with any time I have polynomials. We'll talk about in the second half of this video about questions that don't involve polynomials, but we're not ready for that yet. So in the next question, while it's not strictly a polynomial, I still use the same strategy. So my question is going to be the square root of 9x squared plus 3x plus 1, and then on the bottom it's going to be 4x plus 2. So this is my first limit. So again, when I have a limit involving infinity, especially with something that looks so similar to a polynomial, all that's being a little bit weird is the square root, I'm going to apply heaviness rules. So the first thing I need to do is determine, is this same heavy, top heavy, or bottom heavy? So what I'm going to do is I'm going to, again, ignore everything that's not the leading exponent. So I'm going to ignore this, I'm going to ignore this. Then what happens is I'm going to see what is the square root of 9x squared. Well, what is the square root of 9x squared very, very similar to? because now we can actually just examine the square root of 9x squared because we sort of got rid of the 3x minus 1. I don't know why I keep writing 3x minus 1. Maybe my brain is fascinated with 3x minus 1. But it doesn't really matter because, again, we can't turn it out because it's not the leading exponent. So when we examine the square root of 9x squared, what is that very similar to? Well, that's just very similar to 3x. Because the square root of 9 is 3, the square root of x is going to be, x squared is x. Then on the bottom, it's going to be 4x. So this is not, again, equal, but it's just an approximation, so we'll put an approximation. But notice, what do we have here? What do we have here? We have a same heavy question. So same heavy is always the ratio of the leading coefficients. Notice that it's to the 1, to the 1, to the 1, and then the square root of squared is basically to the 1. So what's the answer here? Nothing too crazy. It's just going to be 3/4. The ratio of the leading coefficients of the top and the bottom. So these questions are also pretty easy, but unlike other same heavy questions when it's strictly a polynomial over a polynomial, you do have to be careful about negatives potentially. So let's just see that in action. So we're going to do the limit as x goes to negative infinity, square root of 25x squared, that's a 2. I want 25 minus, let's do plus 8x minus 4. I don't think we've done that. Over, let's do 7x plus 2. So this is my next question. So this question is going to be very, very similar, except instead of going from x to infinity, we're going to negative infinity. So it's the same idea, of course. We'll change this to an approximate. When we plug in this infinity or negative infinity, we always ignore everything that's not the biggest thing. So I'm going to ignore this basically. I'm going to ignore this basically. What is the top really similar to? Well, square root of 25x squared. Once you've ignored the lesser terms, the terms that don't matter at all, that term is really similar to 5x. Then the bottom, of course, is 7x. We again had a same heavy situation, so you might think that the answer is 5/7. But unfortunately, the answer is not 5/7, because what's happening is that the negative is playing weird things with the square root is doing weird things with the negative. So for example, let's say you have the number -8. When you square that number, you're going to get 64, and then when you square root 64, you are just going to get 8. So you actually don't end up with what you started off with. You started off with -8 and you ended up with 8. So we need to test, just like we did with top heavy, we need to test these negatives and just plug it into the original, really just the leading exponent, but let's keep the square root of x squared because this is not 5x, it's actually plus or minus 5x because the square root and the square root could potentially get rid of the negative. So all you do is the same thing as top heavy. What we're going to do is we're going to plug in negative infinity into this guy right here and just see the sign. Well, the sign, the negative gets squared, so it goes away. Then we take the square root, so it remains positive. So just like with those top heavy examples, I like to write, is the numerator positive or negative? In this case, it's positive, because again, the negative is getting canceled out by the square. And the denominator, it's just 7x. So when we plug in negative infinity, we're going to get negative something. 7 times the negative infinity. So we're just going to get a negative in the bottom. What's a positive number over a negative number? That's, of course, going to be negative. So this is the answer here. So you can see how this question is very, very tricky. If you approach the question just like the previous one, you'll immediately think that the answer is 5/7. And if this were a multiple choice question, and I was trying to trick students, which I like to do, of course, I would have 5/7 as an answer. So that's why you want to be careful. Just keep in mind the warning that anytime you're dealing with top heavy questions or what I call the square root same heavy questions, which is this is an example right here, you just want to be careful with negatives. Plug in negative into the leading exponents of the original. See if the numerator and the denominator are positive or negative, and that will dictate, the ratio of those two things will dictate whether the final answer will be positive or negative. So that concludes most of the questions that you might come about with limits involving infinity, but there are some slightly harder ones that I want to talk about now. So I'm going to erase this. So the harder ones are questions that are not polynomials. Because polynomials, of course, we can do same heavy, but without polynomials, we cannot do that. I do not do polynomials, but we need to first talk about a certain thing. So again, we probably should have started off with this, but what happens when you have limit as x goes to infinity of just a single thing, like x to the third? What this means is that you're letting x get bigger and bigger and bigger. So when you plug in infinity into this, you're just going to get infinity. This is technically top happy, for example. Same thing if you have something like limit as x goes to infinity of 3 to the x. Because what does this mean? Again, x is not a number, so all we're doing is we're multiplying 3 a bunch of times, so we're going to get infinity as well. When we say we get infinity, we just mean that the answer is going to be unbounded. So my question is, what happens when you have fractions? Same thing with this bottom example. So when we have limit as x goes to infinity, for example, 3 to the minus x, this is what we're going to try to do. How do you find the limit of this guy? So this is no longer a polynomial, of course, because it's x is in the exponent, but we're going to treat it similarly. The first thing I do is I treat the negative exponent. I just apply rules of negative exponents. Negative exponents means you have things in denominators. So what I'm going to do is I'm going to rewrite this. This is pretty messy, so let me try to write it a little bit neater. So I'm just going to rewrite this as limit as x goes to infinity of 1 over 3 to the x. So what happens here? I'm going to do a little bit of abuse in notation, but I think it's easier to abuse notation in this case. So what we're going to do is we're going to plug in infinity. We're going to see what we get. We just said that when we plug in infinity, we're going to get 1 over infinity. So we don't have to write the limit anymore. So again, we just said that when you plug in infinity into 3 to the x, you get infinity. So that's just in the denominator, 1 over infinity. And this has no meaning because we're doing 1 divided by a concept. Infinity is a concept. But what I mean, of course, is that I'm just dividing 1 by a bigger and bigger number. And the question is, what is this guy? What is 1 divided by infinity? So what is 1 divided by infinity? That's going to be 0. And why is that the case? Well, what I want you to think about is, let's say we have a candy bar. If you have a candy bar and you split it into 2 people, well, both people get a certain piece. But if you split that one candy bar amongst 1 million people, amongst 1 billion people, amongst 1 trillion people, every single person gets a smaller and smaller piece. So when we split it amongst a trillion, I don't know any numbers bigger than that, but if you split it again amongst a bigger and bigger and bigger number, that means everybody's individual piece is getting smaller. Eventually, as your number gets so big, you're eventually approaching 0. So this is sort of the argument I'm going to use as I do these limit questions. Again, it's not the best way to write this, but I think it's the most intuitive way. Thinking about what is 1 over infinity, or what is infinity over a number, what is those ratios, and the one that we want to think about the most is a constant over infinity is going to be 0 because you're splitting up a finite number of things amongst an infinite number of things. So let's just see this in action in harder questions, maybe 1 or 2. So let's do this. So I have this question right here. Limit as x goes to infinity. Let's do negative infinity. Let's do infinity first. Keep changing my mind. Let's do e to the x negative x plus 3 over 5 minus e to the minus 3. So this is my first question. Yeah, this is good. So what happens when we're going to plug in infinity? So again, I'm not doing any of the things that we talked about in the beginning. We're not going to be talking about heaviness because when we introduce heaviness, that only applies to polynomials. We are going to be doing our e's, something to the x and not x to something, a little bit different. So what I like to do is I just like to plug in infinity and just like to survey the scene, sort of, so to speak. So what we're going to do is we're just going to plug in infinity anytime we have an x. So it's going to be e to the minus infinity plus 3 over 5 minus e to the negative infinity. So whenever I have a power to the negative infinity, what I like to think about is writing it as that negative exponent. So this is going to be 1 over e to the infinity, writing the negative exponent as fractional, is what I mean, plus 3 over 5 minus e to the 1 over e to the infinity. So again, in this step, all I did was I converted e to the negative infinity into fractions. And unfortunately, we do have fractions within fractions, but you'll see that it's not too bad. What is e to the infinity? What is the denominator of these smaller fractions? Well, when you multiply e, which is around 2.7-ish, a bunch of times, it's just going to get bigger and bigger and bigger and bigger and bigger, and that means that these terms are going to infinity. So we're going to get 1 over infinity. Let's make it a little bit neater. Plus 3 over 5 minus 1 over infinity. And what is 1 over infinity? Well, we just talked about it. You have that one candy bar, you're splitting it up amongst an infinite number of people. That's going to be eventually tending towards 0. So it looks like we have 0 plus 3 over 5 minus 0. And then what is the answer, of course? Well, the answer is going to be 3/5. So hopefully you can see sort of my process here. It's very, very bad notation. A lot of math teachers would frown upon this, but who cares about them? What we're trying to do is we're trying to make this as intuitive and easy as possible. So when we have things that are not polynomials, unfortunately we can't apply heaviness, or it's very difficult to apply heaviness. We might miss the question. So what we do instead is we're just going to plug in infinity and slowly examine the question, slowly simplify things. For example, when we plug in infinity, we got e to the negative infinity. I like to write that as a fraction instead. Anything to the infinity, if it's bigger than 1, as you multiply terms and terms and terms, you're going to get infinity. If you have a finite number divided by infinity, even if this were a million divided by infinity is still going to be 0. Then notice that our final answer is just 3/5. So let's just do one more example, very similar to this, and let's call it a day. So I'm going to erase this. So here we go. Let's be a little bit tricky. Let's do negative infinity. Let's do 2 to the x plus 3. And then let's just do sine of x. Something kind of crazy. Sine of x. No, I don't want sine of x. That's too weird. We'll do sine of x in the next question. So I just lied. I just said we're going to do one question. Let's just do 2 more. Sorry about that. Sometimes I lie. So this is going to be 4 minus 2 to the x. So this one's going to be very similar to the previous one. So again, we have, instead of x to a number, x squared, we have 2 to the x. So I don't want to apply same heavy rules. All I'm going to do is I'm going to plug in negative infinity anytime I have an x. So it's going to be 2 to the negative infinity plus 3 over 4 minus 2 to the negative infinity. Anytime I have something to the negative infinity, I like to write it as a fractional exponent. So it's 1 over 2 to the infinity plus 3 over 4 minus 2, 1 over 2 to the infinity. What is 2 to the infinity? Well, you're just multiplying 2 a bunch of times. You're never going to get to a number because it's getting bigger and bigger and bigger. So these are going to be 1 over infinity. The bottom is going to be similar. It's going to be 4 minus 1 over infinity. Hopefully you can see my work here. Getting kind of small at the end. But 1 over infinity again is 0, so we can cross those out. You're eventually going to just get 0 plus 3. That's the worst 3 I've ever drawn. This thing is 0, and then you're going to get 4 minus 0. That's 3/4. So this is this answer. So again, just apply this process slowly, even if it's not the most precise process, and you should get the answer. Just being very, very careful with infinity. So the very last question, I don't believe is on the 8th exam, but we can always talk about it. It might appear on college calculus exam, for example, is stuff with limits involving infinity, but also involving trigonometry. So we have this. Last question of the day. Real last question. Not lying to you, I promise. So let's do x squared plus 2, and let's do x squared minus sine x. So if you cover this up, notice that this would be a polynomial over a polynomial, and that's going to be our same heavy ideas, because x squared plus 2 over x squared, the leading exponent would be 2. So that's what the sort of approach that I want to do here, because if I cover this up, it would basically be a polynomial. The annoying part about this is, of course, the sign. What happens when you plug in sine to infinity? Well, if you don't know, sine oscillates like this, like ooh, ooh, ooh. But no matter if you go to infinity, you'll just see that it'll just keep oscillating forever. So that the limit as x goes to infinity of sine of x actually doesn't exist, because you're just oscillating, 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 oscillating. But Notice that sine of x, no matter what happens, and same thing with cosine of x, as I oscillate, I still never get smaller than -1 or bigger than 1, because the range of sine of x and cosine of x, by their definition from the unit circle, are in between -1 and 1. So note, sine of x is in between -1 and 1. So what I'm going to argue is that this sine of x is basically like a constant. It's not really a constant because it's still oscillating, but it's a number that's smaller than this 2, for example. We know that it's in between -1 and 1. So when we apply same heaviness, which I'm willing to do for these questions, as opposed to the e to the x questions or 2 to the x questions, what I do is I just treat this sine of x like a constant, even if it's not a constant, because I know it's not going to get any bigger. It's not like an x cubed term that gets super, super big. This sine x remains between -1 and 1. So when I do heaviness, this is not going to be the leading thing. X squared is going to be the leading thing. So what happens is I can mark this out, look at what we have, our friend is same heavy, x squared over x squared, this answer is 1. So this video has been a little bit longer than I expected, but hopefully you know how to do limits involving infinity. Let me just recap a little bit. Anytime you have a polynomial over a polynomial, you always look at the leading exponents, the leading exponent, or the exponents of the leading terms, and you see how they compare. If you have bottom heavy, which means the denominator is bigger, the leading exponents of the denominator, that answer is always 0. If you have same heavy, meaning that the leading exponents are the same, that means that the answer will be the ratio of the leading coefficients. And finally, if the numerator's exponent is bigger, that means you have top heavy. And top heavy's answer is either infinity or negative infinity. Keep in mind that when you have those top heavy questions, infinity or negative infinity, same thing with the square root same heavy questions, you do want to plug in negative because you want to be careful of negatives. Is the answer infinity or negative infinity? Is the answer 3/4 or negative 3/4 in those same heavy square root questions? And those usually just come by just plugging in a negative into the leading terms as we did. Finally, same heavy questions are usually applied to polynomials. So if you have something exponential, like e to the x or 3 to the x or 5 to the x, and you still have limits involving infinity or negative infinity, you should just try to plug in infinity or negative infinity and slowly work your way through using rules of infinity. Like infinity over a number is infinity, a number divided by infinity is 0, because you're splitting up that thing into an infinite number of parts. But hopefully this video made sense. No matter when you're watching this video, whether you're learning limits for the first time or whether you're going to be applying derivative rules and limits, this video will actually appear in 2 playlists. No matter what, I don't think these limits are too bad, especially those heaviness questions. Hopefully I'll see you again in the next video as you practice harder limit questions, no matter what video that might be, of course. Keep in mind that just like normal, we have a Girls Teach Calculus video where one of my former students practices all these types of questions, bottom heavy questions, same heavy questions, top heavy questions, questions that involve negatives, the same root questions, the same heavy square root questions, the e to the x questions, the exponential questions, potentially questions involving sine of x, so be on the lookout for that. Of course, I'll put that in the description below. But for now, thanks again for watching, and I hope to see you in a future limit video as we continue our journey of limits. Thanks again for watching.